Okay, YouTube, in the last couple of videos, we've looked at finding the inverse of a 2 by 2 matrix, and we've done one, generally speaking, and we've done another one with a shortcut. In this video, what we're going to look at is just 3 by 3, 4 by 4, and any square matrix of order 3 or higher, how we would find the multiplicative inverse for that invertible matrix. So we're going to do it by hand, but we're certainly also going to check it on a calculator as well. I want to see how you could get this on a calculator. So it says, to find A inverse for any n by n matrix A, for which A inverse exists, here are the steps we're going to take. And so the interesting story is these are the 3 steps we took with a 2 by 2. We're just looking at a 3 by 3 example. So the first thing we do is we form the doubly augmented matrix where we have A on the left and our identity on the right, where IN is the multiplicative identity matrix of the same order as the given matrix A. So when we write our doubly augmented matrix here, let's go ahead and start with that. I'm going to try to keep things a little bit small-ish here. It's going to look like this, where we have on the right side, of course, our identity matrix of order 3, since our coefficient, well, I'd say this matrix is of order 3 by 3. So we say 1, negative 1, 1, 0, negative 2, 1, and negative 2, negative 3, and 0. What we're going to be doing is performing row operations on A augmented with I to obtain the matrix of the form I on the left and then B on the right. So that is to say that what we're going to be doing is using Gauss-Jordan elimination to transform this matrix A on the left into the identity matrix. We're going to make it into the identity matrix, and what results, this matrix B on the right, that is the inverse matrix there. So let's go ahead and proceed with this. Really, this is going to be a whole lot of just Gaussian elimination. So let's go ahead and start with the fact that we want to start by getting a 1 in the top left corner. Now, in this particular case, we do have a 1 up in the top left corner. We just want to get zeros underneath it. So neat story is we already have a 0 here. We only need to take care of this 2 right here. So what we're going to do is we're going to use that 1 in the top row. We're going to multiply it by a positive 2. So we say 2 times row 1. And we're going to add that to row 3, since 2 is the opposite of this negative 2. So row 1 is not any different here. Row 1 stays the same, 1, 0, 0. Row 2, okay, row 2 is still the same thing here, 0, 1, 0. It's just that in row 3 now we would have a 0 here. Let's go ahead and look across this though. We're going to double the entire top row and add it to the third row. So if we took 2 times negative 1, we get negative 2, and negative 2 plus this negative 3 here, we would get a negative 5. If we take 2 times 1 and add that to a 0, we would get a 2. If we took 2 times 1 here and add it to this 0, we get a 2. 2 times this 0 plus 0 is 0. And 2 times this 0, 0 plus 1 is 1. So all we've done so far is gotten a 1 on the top left and get zeros underneath. Well, now our next job is to get a 1 right there. And so in order to do this, I suppose we're going to have to take it times its reciprocal here. In this particular case, the reciprocal of negative 2 is negative a half. So we say negative a half times our second row. Well, our first row wouldn't change. Okay, first row stays the same now for good. Here, our third row, we didn't operate on it in this particular step. So we're going to just take everything in the second row times negative a half. So we get 0 times negative a half is 0. Negative 2 times negative a half, of course, is 1. And 1 times negative a half is negative a half here. 0 times negative a half, 1 times negative a half, and 0 times negative a half. So with our new second row, what we're going to do is we're going to leverage our 1 here in order to eliminate the 1 above it and the 5 below it. So in terms of what we typically do, of course, we would take that 1 times the opposite of these two values here and add it onto those rows to get these two values, negative 1 and negative 5, to cancel out. So the opposite of negative 1 is certainly 1. So we're going to take 1 times row 2 and add that back onto row 1. And the opposite of negative 5 is positive 5. So we're going to say 5 times row 2. We're going to add that onto row 3. So row 2, let's go ahead and fill in row 2 here. Row 2 is not going to change. We are changing the values of the other two rows in this particular step. So let's go ahead and do our math now. We'd say if we took 1 times this 0 plus 1, we still get a 1 here. 1 times 1 is 1. Plus 1 is a 0 here. So there's our benefit to doing it this way. We'd say if we took 1 times negative a half plus 1, we would just get a half. Okay. If we were to take now, let me fix this here. If we were to take 1 times 1 or 0 plus 1, we get 1. 1 times negative a half plus 0 is negative a half here. And then 1 times 0 plus 0 is 0. So now let's move on and do our third row. We were going to take the whole second row times 5 this time and add it to the third row. Well, 5 times 0 plus 0 is 0. 5 times 1 plus 5, of course, is 0. 5 times a negative a half would be negative 5 halves, and we're adding that to 2. So now we need to get a common denominator here. I suppose we'd say 4 halves. This would be negative a half. So we get a negative a half here. Moving onward, I suppose we would say 5 times this is 0 plus a 2. That'd be 0 plus 2 is there. 5 times negative a half plus 0. That'd be negative 5 halves. And then we would say 5 times 0 plus 1 is 1. So now we've got a 1 in the first column, 0's underneath. A 1 in the second row, second column, and 0's above and underneath. Now we want to get a 1 here. And of course, to get a 1, we always just take that thing times its reciprocal. So we're going to take everything now in the third row times the reciprocal of negative a half, which is negative 2. So we say negative 2 times row 3 here. So row 1, 1, 0, 1 half, okay. 1, negative 1 half, 0. Row 2, 0, 1, 1 half, 0, negative a half, 0. And then our last row becomes 0, 0, 1. And if we were to take negative 2 times this positive 2 here, we get a negative 4. If we were to take negative 2 times a negative 5 halves, this is pretty cool here. We get a positive, and also the 2's would cancel out, so we get a 5. So this would be a 5. And then last but not least, negative 2 times this 1 here would be a negative 2. So with this matrix, essentially we're almost done. What we need to do now is use this 1 to crash into the things above it. So we're going to take this last row, this third row, times the opposite of these two values above it here, which is in both cases going to be a half. So what we see happening here is this. We would get our two row operations as being negative 1 half times row 3, and we're adding these back onto the first rows here. Negative 1 half times row 3 plus row 1. So row 3 is not going to change. We have a 0, 0, 1. And down here we have a negative 4, a 5, and a 2. So multiplying these out, I suppose if we did negative a half times our third row here, we're going to get negative a half times 0 plus 0 is 0. Negative a half times 0 is 0 plus 1 is 1. Negative a half times 1 plus positive a half, that's going to give us that 0 there. As a matter of fact, we're going to get a 0 here as well. But let's go ahead and take a look at what else we have. If we did negative a half times a negative 4, negative a half times a negative 4 is a 2. We're going to add that 2 back to this 0 here, so we get a 2. Negative a half times 5, negative a half times 5 is negative 5 halves. We're going to add that to our second row. So negative 5 halves plus the extra negative a half we have in the second row here is negative 6 halves is negative 3. So we get a negative 3 here. And if we did negative a half, okay, times this negative 2, we get 1, and 1 plus 0 is 1. So now working on our top row here, I'm going to go ahead and fill these in just because we know we've caused this to happen. Let's look at these last three entries here. We're doing a negative a half times row 3 again, but adding it back to our first row. So when we did negative a half times a negative 4, okay, we got a positive 2, and 2 plus this 1 that was up here is 3. If we do negative a half now times a 5, we got negative 5 halves, and we're taking that negative 5 halves here and we're adding it back up to this entry here. So this time we get a negative 5 halves plus a negative a half. Again, we get negative 6 halves as a negative 3. So we get a negative 3 here. And then last but not least, negative a half times this negative 2 is 1, and 1 plus 0 is 1. So what I want to do is I want to suggest that this now on the left is I and this on the right is B. Therefore, this B is equal to A inverse. And we could say that A inverse exists, and we know it as this 3 by 3 matrix, 3, negative 3, 1, 2, negative 3, 1, negative 4, 5, 2. And I suppose the way we would check this is take it times the original matrix here to make sure that they're actually indeed inverses of one another. So what I've done to save some time especially is I went ahead and I put in matrix A here. As you can see, this 3 by 3 matrix up over here. And what I want to do is I want to just kind of point out to you on a matrix how we would type in A inverse. And so one way to do this would be just simply to take A, which is in our matrix menu here, and there's this x to the negative 1 key. If you hit this, then this looks like how we write A inverse. And usually that x to the negative 1, what that does is it reciprocates something. But in our case with matrices, our TI calculators know that this means A inverse. And if we hit this here, we can check out our inverse matrix to see how well we did. It looks like we got 3, negative 3, 1, negative 2, negative 3, 1, and negative 4, 5, and 2. And so even right here, I can see that I've probably made an addition error, and I have to go back and check this again. But we should have got a negative 2. I suppose that has to deal with a positive or a negative in there. But that's how we find the inverse of a 3 by 3 matrix and the steps you take in order to do that and how you do it on the calculator. Cheers.